a volatile and highly energized atmospheric setup triggered a dangerous outbreak of severe weather across north-central and northeast Kansas on Monday evening, May 18, 2026. The regional meteorological event culminated in the generation of at least 7 confirmed tornadoes, alongside widespread, destructive straight-line winds, torrential downpours, and severe flash flooding. According to comprehensive storm assessments released by the National Weather Service, NWS, forecast office in Topeka, the multi-vortex convective system ripped primarily through rural communities and agricultural lands. This specific geographic path miraculously prevented any loss of human life or major physical injuries. The sheer mechanical force of the supercell storms left behind a multi-million-dollar trail of ruined agricultural infrastructure, flattened utility grids, uprooted ancient trees, and compromised residential structures. The convective event, which had been anticipated by regional storm forecasters for several days, escalated rapidly during the mid-afternoon hours of Monday as a potent, fast-moving cold front advanced from the northwest. This cold air mass slammed violently into a highly unstable, moisture-rich and warm air tongue extending northward from the Gulf of Mexico. The resulting atmospheric instability created the perfect thermodynamic breeding ground for long-lived, rotating supercell thunderstorms capable of maintaining multiple updrafts and producing violent tornadic funnels. The atmospheric breakdown began to manifest visually at approximately 3 p.m. Central Daylight Time, CDT, as radar imagery indicated intense convective initiation along the primary boundary line. Over the course of the subsequent 4 hours, the storm system systematically spawned 7 distinct tornadic funnels across 5 separate counties. The first significant tornadic life cycle began in Clay County at 3:27 p.m. Central Daylight Time. Spotters and atmospheric scientists tracking the cell documented a high-contrast, condensed rope tornado, touching down approximately 5 miles west-southeast of the rural community of Edina. At 4:03 p.m. Central Daylight Time, a more intense and structurally sustained tornado materialized in Washington County. The storm system dropped a tornado roughly 3 miles southeast of the town of Palmer. This particular vortex was later officially classified as an EF1 tornado on the enhanced Fujita scale. Ground survey teams noted that the tornado remained on the ground for an estimated 4 minutes, carving a localized path of destruction where it systematically snapped heavy tree limbs, uprooted mature oak trees, and completely defoliated natural vegetation along its route. As the supercell complex continued its relentless march toward the northeast, it entered Marshall County, which ultimately bore the brunt of the tornadic density. At 5:15 p.m. Central Daylight Time, experienced storm chasers and local emergency personnel confirmed the touchdown of a third tornado roughly 3 miles south of Waterville. This initial Marshall County funnel dissipated quickly, only to be replaced minutes later by a much larger and significantly more destructive vortex. At 5:27 p.m. Central Daylight Time, a powerful EF1 tornado developed approximately 1 mile east-northeast of Blue Rapids, packing maximum peak winds estimated by structural engineers to be around 95 miles per hour. This tornado carved a continuous, punishing path measuring 12.01 miles in length. The storm directly targeted agricultural infrastructure, ripping apart metal outbuildings, destroying heavy grain bins, lifting specialized farming equipment, and shattering power poles like matchsticks. Simultaneously, a secondary atmospheric circulation developed within the trailing edge of the storm complex, resulting in a brief secondary touchdown at 5:30 p.m. Central Daylight Time, just 1 mile north of Wakefield back in Clay County. This brief spin-up was witnessed and confirmed directly by an off-duty National Weather Service employee who was actively monitoring the storm's rear flank downdraft. By 5:38 p.m. Central Daylight Time, Marshall County was struck yet again. Emergency management officials reported that a 6th tornado had materialized roughly 5 miles northwest of Frankfort. This funnel targeted heavy agricultural operations, dealing extensive structural damage to localized grain elevators, lifting the roofs off several barn structures, and completely blocking secondary rural highways with heavy timber and organic debris. The final and historically most intense tornado of the evening occurred further east in Nemaha County at 7:16 p.m. Central Daylight Time. A massive supercell dropped a tornado approximately 5 miles northwest of Sabetha. Surveyors classified this final event as an EF1 tornado, but noted that it carried peak wind velocities pushing 100 miles per hour, right on the threshold of an EF2 classification. The tornado completely leveled a large modern barn structure, obliterated multiple adjacent outbuildings, threw heavy metal debris hundreds of yards into neighboring fields, and snapped a long string of high-voltage utility poles before finally lifting into the low cloud base as the storm crossed toward the Nebraska border. In Leavenworth County, a trained emergency management coordinator recorded a monstrous straight-line wind gust of 92 miles per hour, 148 kilometers per hour, at precisely 8:55 p.m. Central Daylight Time, near the town of Jarbalo. Winds of this velocity possess kinetic energy comparable to a low-end hurricane or an EF1 tornado, but spread over an area spanning several miles wide rather than a narrow track. In Shawnee County, sustained wind forces regularly clocked in between 60 miles per hour and 69 miles per hour for an extended period, creating a relentless buffeting effect on commercial and residential structures alike. The immense physical strain caused by these widespread winds wreaked unprecedented havoc on the regional electrical transmission grid. High-voltage lines were pulled down by falling limbs, and dozens of rotting or older utility poles snapped under the wind load. Evergy, the primary electrical utility provider for the state of Kansas, reported massive, instantaneous blackouts as the storm system moved directly through major municipal distribution nodes. In the Topeka municipal area, over 4,000 homes, retail centers, and industrial facilities were plunged into complete darkness within minutes. In the Manhattan metropolitan zone, more than 2,700 customers lost power as substations automatically tripped to prevent catastrophic system overloads. In response to the escalating utility emergency, Evergy deployed hundreds of specialized line technicians, damage evaluators, and tree-clearing contractors. Working under highly hazardous night conditions, characterized by continuous lightning and ongoing rainfall, these emergency crews worked tirelessly to isolate broken circuits, replace shattered crossarms, and string new conductors. By daybreak on Tuesday, May 19th, utility spokespersons announced that power had been successfully restored to approximately 85% of all affected urban customers, though full restoration for isolated rural agricultural hookups was expected to take several days due to difficult ground terrain muddy conditions. The city of Manhattan, Kansas, home to Kansas State University, found itself directly in the crosshairs of a training convective cell. Localized rain gauges recorded up to 3.5 inches of precipitation, falling in less than 2 hours. Because the urban concrete and storm drainage systems were utterly incapable of processing such a massive volume of water so quickly, major roadways were instantly transformed into rushing rivers. The Manhattan Fire Department experienced one of its busiest nights on operational record, responding to over 40 distinct storm-related emergency calls in a 4-hour window. Firefighters utilizing specialized swift water gear successfully extracted 12 motorists who had mistakenly driven their vehicles into deeply flooded underpasses where water levels rapidly rose past vehicle hoods. Crews rushed to extinguish multiple small-scale fires sparked when downed live power lines fell onto residential roofs or came into contact with metal commercial fencing. Structural shifts caused by uprooted trees breaking underground service lines forced emergency crews to systematically isolate natural gas mains across several residential blocks. By early Tuesday morning, as the skies finally cleared and the floodwaters receded into regional tributaries, public works crews using heavy front-end loaders cleared primary thoroughfares of thick mud, shattered glass, and displaced gravel. To assist citizens dealing with property damage, Riley County authorities officially waived all disposal fees at the Riley County Transfer Station, allowing residents to haul unlimited amounts of downed trees, shattered limbs, and organic storm debris free of charge. Meanwhile, in Newton and North Newton, destruction of an 80-year-old barn south of Hutchinson in Abbeville, and some significant structural damage, including a collapsed outbuilding on a rural property southwest of Conway Springs. Notable storm reports from Monday night included egg-sized hail in Lincoln and Haviland, golf ball-sized hail in Kinsley, and recorded 70 miles per hour wind gusts in Hutchinson, Garden Plain, and Newton. The wind report in Garden Plain is from the same storm that caused damage southwest of Conway Springs, about 20 miles south of Garden Plain.